Guys, I'm back with a new video. In this video, let us learn about linked lists. Now, linked lists is a linear data structure. Unlike arrays that we had discussed in the previous video, linked list elements are not stored at continuous locations. The elements are linked using connections. Suppose you have a linked list of numbers. So 1 points to 2, then 3, then 4, like this. And this points to say nothing or null. Now, the very first node of the linked list is known as the head of the linked list. Then we have a next pointer that points to a node of same type. So each of these circles represent a node. Now we know that arrays can be used to store linear data of homogeneous types. Because of the limitations of array that the array size is fixed, that we must know the upper limit on the number of elements for the array that we are trying to create. That is, you must define the number of elements at the compile time. Now, second limitation for arrays is that inserting a new element in an array of elements is an expensive operation, because first you have to create a room for the element that you want to insert at a specific position. For that, you have to shift all the elements that are present to make the room for that element, or make the spot for that element, and at that spot you insert an element. So which means that you need to shift all the elements one position to the right or left as per requirement, and therefore the insertion is an expensive operation in case of arrays, which is not the case with linked list, which you will see in this video. Now, linked lists have following advantages over arrays. They are dynamic in nature. So if you want to add more nodes to the list, you can simply create a node and then you can connect that like this. If you want to create more nodes, you can connect them like this. Very easy to do. Even if you want to insert a node at a specific position, say at index, say right after 3, you create the node and you break this connection, this link, and connect them like this. And then this becomes 1, 2, 3. Then right after 3 we have now 5. Then after 5 we have 4. Then another 5, 6, 7. So they are dynamic in size. And there is an ease of insertion, as you can see. You just have to adjust the links and it's done. Now there are some drawbacks for linked list as well. In case of linked list, the random access is not allowed. We have to access elements sequentially, starting from the very first node, from the head node. So first you access the first node, then the second node, then the third node. So access is going to happen sequentially. Now this node should have the information that to which node it points to. So we need to store, or we need to have some extra memory for this link in the node itself. Third thing is that the linked lists are not cache friendly. Now since array elements are stored in continuous locations, there is a locality of reference, which is not in case of linked lists. Now linked list is represented like this, where each circle represents a node and the very first node is known as the head node. And if the list is empty, then this value of head is null. Now each node in a list has some data and a pointer, or you can say reference in case of Java, next. And this next points to an element of same type, which is node. So this next is of type node, and data can be of any type. It can be a character, it can be an integer as well. So now we know what a linked list is. Let us define a linked list and solve some simple problems in this video before we move forward with some more complex problems pertaining to linked lists. Now let me tell you the structure of the node that we will be using in this video. So our node will look something like this. It will have some data, and it will have a next reference that points to an element of same type, which is node. So now let us define some utility functions for the linked list that we will be requiring before we start solving some good questions on linked list. So on the screen you can see we are having a public class linked list, and right here first let us define a class of node. So this node class will only be accessible from right inside this linked list class, which is publicly available to us. And this class can only be accessed from within the class and not outside. Now a node will have some data. Let us use numbers for now, so in data, and a next reference that points to an element of same type, so type will be node here. Then let us define the head of the linked list and private node head. Then let us define a tail node as well for the linked list. Now the tail represents the last node of the linked list, and it will help in certain problems. So for now just follow what I'm doing here. Tail of the linked list, private node tail, and then let us define a variable for the size of the linked list. Private int size. And then let us define a utility method that will just return the size of the linked list. So int size and return size like this. And then let us define a simple method to check whether the linked list is empty. So boolean is linked list empty and return this check. So if the size of the list is 0, this means that the list is empty. So in that case, this check will get evaluated to true. Otherwise, this will get evaluated to false if there is at least a node in the linked list. Then let us define a utility method to get the first node of the linked list, which is the head node. So right here, int get head node data, return this dot head dot data. So this refers to the current instance of the linked list that we are working on. We will create an instance of the linked list class in just a minute. So for now, just follow. This refers to the instance or the object of the linked list that we will create. And for that linked list, we want the data of its head, which is this dot head dot data. Then let us define the utility method to get the last node of the linked list. So int get tail node data and return this dot tail dot data. Now in this video, let us define our very first problem. That is, we need to add a node to the linked list. So how we can achieve this? So we have to define a method to add a node at the start of the linked list, which is problem 1. So let us first discuss the idea behind this and then we will code this out. So suppose currently we are not having any data or we don't have the linked list with us and we want to add a value of 7 to the linked list. So this should become the very first node of the linked list. So what are the steps for introducing this value as the first node of the linked list? So the very first thing we need to do is we need to create a node and then we need to add this data into that node. And then what we need to do is we need to set our head to this node and our tail to this node as well for the very first node. So currently we are only having this node in our linked list and no more elements in the list. So this node represents the head as well as the tail of the linked list because we are having only one value in our list. And since you have added a node to the linked list, you can do size ++ to increment the size of the list to maintain into the record that now the list size is 1. Now this is the case for 0 size. Now when the list has size of 0, then this is how insertion is done. But suppose this 7 was already there in the list, which is the current state, right? What if you now want to add a node at the start of the list? Suppose I want to add 3 to the list. Now for 3, we first have to create a node like this. And let us be a little clear on this. This is a node with a value of 7 and currently it is the head and the tail as well for a single node, right? Now we want to insert 3. So we create a node and in that node we add the value 3. Then the next of this node, which is this link, is made to point to the current head that we are having. And then this head is made to point to 3. So our new head is 3. And then we increment the size of the list by 1. So size ++. So now the size is 2. And this is how we do adding a node at the start of the list. So let us write the code for this. This is a method that has a return type of void. So void add at start. And this takes on some value. Let us first add the case for empty list. So if the size of the list is 0, then in that case we are going to insert the very first node of the list. So for that, let us define a function handle 0 size addition and pass on the value to that. So the 0 size addition function is also a void type, void handle 0 size addition. This takes on a value. Now the very first step is to create a node. So node, new node. So using new, you can create a new instance of the node. Now we need to add some data to this node. So node.data and add on this value to that node's data. Since this node is going to become the very first node of the list, just like I explained, set the head to this node and the tail to this node as well. And since this is going to be the very first node of the list, you need to increment the size of the list by 1. So size ++. So this is the case for handle 0 size addition. Okay, so this should be like this. And this should be handle 0, not handle A0. Now for our simple case where we are having at least a single node in our list, the very first step is to create a node first. So create a node, new node, and then add some value to it, which we are getting right here. So node.data, set that to the value that the user passed us as the argument, and then the node that we just created has to become the first node of the list. So the node that we just created, its next reference should point to the current head, right? So now we are having a new start node. So what we now need to do is need to shift head to this node and then increment the size of the list by 1 like this. So this is the case that I'm talking about. Now once we create a node, we have a value inside it and its next reference is pointing to the head node, and this head is now being made to point to the value 3 for this example, because 3 is going to become the first node of the list. And now we increment the size of the list by 1 by saying size ++. So this is the logic for add at start. So now let us define the method to display the linked list. So let us go right here and define a void function display, and the very first thing we need to do is we need to set a reference and let us point that to the head of the list. Now as long as the pointer is not null, we are going to do some piece of work. So first we are going to print the node data on which the ptr reference is currently pointing at. So system.out.print ptr.data, let us give some space here, and then we need to increment the reference to point to the next node by saying ptr equals to ptr.next. So once we have printed the entire linked list, we can leave a line by saying system.out.println, and let us understand this function now. So suppose our linked list is 1 7 6 5 3 and we need to traverse over this list. So to display all the elements of the list, the very first step is to set a reference to the head of the list. So this is our head. Let us set a reference ptr to the head of the list. Now as long as this reference is not null, so currently it is not null, we are going to print the data that is sitting under this reference, which is 1. So we print 1, and then we increment the reference to point to the next node in line, which this node's link is pointing to. So now our ptr is being made to point to 7. Again, this reference is still not null, so we are going to print 7, and then we increment the pointer so that it now points to 6. We print that. We again increment the pointer, it now points to 5. We print that. We again increment the pointer, it now points to 3. We print that, and we again increment the pointer. Now the pointer points to an invalid location, so this is null. So now our pointer is pointing to null. We come out of the while loop and we leave a line. So this is the output that we get when we traverse over the linked list, right? So let us see these methods in action. So right here, let us define our main function, and here I will first create an instance for the linked list. So new linked list, and let us call the add at start method that we defined for the linked list, and let us add a value of 1, and then let us copy this and paste it down below multiple times. Change this to 2, 3 and 4. And now for displaying the linked list, let us say linked list.display, and now let us run the file to see the output. So javac linked list.java, and now to run the file we can say java linked list and press enter. So now you can see we are getting 4 3 2 1. So let us understand how we are getting this. So as you can see here, we are adding 1 to the start of the list, so 1, and then to the start of this list we are adding 2, so 2. To the start of this list we are adding 3, and to the start of this list we are adding 4. And now we know the logic behind this, that how this addition is actually taking place. So let's move on to other problems in the next video.